Simplification of Boolean functions using Carnot maps. Carnot maps can also be called as K-maps. My topics are Introduction to Boolean function, Need for K-maps, Structure of K-maps, 2 and 3 variable K-maps, Grouping rules, Examples of minimization, Advantages and limitations, Applications in digital circuits. Introduction to K-maps. Boolean algebra helps in simplification. It is used in large expressions. K-maps provide a visual method of simplification. It is used to simplify the Boolean algebra functions. Need for K-maps. It reduces the number of logic gates. K-map minimizes circuit cost and complexity. It is much faster in simplification compared to algebraic method. It can reduce the logic gates and it is used to simplify and reduce the number of variables. Structure of K-maps. It is a grid-like diagram representing minterms. Each cell contains one minterm. Adjacent cells differ by only one variable like gray code order. The first cell represents 00 value, it means it is 0th cell. 0001 represents the first cell. 0011 represents the third cell. 0010 represents the second cell. 0100 represents the fourth cell. 0101 represents the fifth cell. 011 represents the seventh cell. 0110 represents the sixth cell. 1100 represents the 12th cell. 1101 represents the 13th cell. 1111 represents the 15th cell. 1110 represents the 14th cell. 1000 represents the 8th cell. 1001 represents the ninth cell. 1011 represents the 11th cell. 1010 represents the 10th cell. 4 cells. In two variable K map, it contains 4 cells. It is represented by two square. Shown in terms as 00011110. 010. The vertical row is represented as 01 and the column is represented as 01. The first cell represents the 0th value and the second cell represents the first value and 10 represents the second value and 11 represents the third value. This is the representation of two variable K maps. Example for two variable K maps. Here f of a comma b is equals to summation 1 comma 3. As b is equals to 0, b is equals to 1, a is equals to 0, a is equals to 1. We have to place 1 at the first position. At b is equals to 1 and a is equals to 1. Place 3 at b is equals to 1 and a is equals to 1. Here the highest possibility is pair b is equals to, here a is equals to 1 and a is equals to 0 has no common terms. So we take the column b is equals to 1 and the function of a comma b is equals to b. Example for two variable K map solution is f is equals to b. Three variable K map. It can be represented as 2 cube and it contains of 8 cells. Arranged as gray code order. The below figure represents the three variable K map. 000 represents the 0th cell, 001 represents the first cell, 011 represents the third cell, 010 represents the second cell, 100 represents the fourth cell, 101 represents the fifth cell, 111 represents the seventh cell, 110 represents the fourth cell, sixth cell. Example for three variable K map. Here f of a comma b comma c is equals to summation 0 comma 2 comma 5 comma 7. It can be placed as a is equals to 0, a is equals to 1 in the column, bc is equals to 0 0, bc is equals to 0 1, bc is equals to 1 1, bc is equals to 1 0 is represented in the row. We can place zeroth value as 1 and the second value as 1 and fifth value as 1 and seventh value as 1 as shown in the figure. Now pair the zeroth position and the second position. The highest possibility in this group is pairing. So we can pair the first zeroth position and the second position. We can get it as 0 represents the complement value in min terms and 1 represents the same value. Here 0 represents A bar, C bar. Next 5 and 7 can be grouped. It can be represented as AC. As we said, 0 represents the complement value and 1 represents the same value. Here 1 represents AC. Grouping rules. Groups of 1 comma 2 comma 4 comma 8. We can group only the powers of 2. Group must be rectangular. Wrap around are allowed. Larger groups gives to better simplification. Group we can group only the powers of 2, which is the highest possibility. If we have the possibility of 16, we group the 16 possibility, or if we have the possibility of 8, we can group 8 possibilities. If we have the possibility of 4, we can make the possibility of 4. If we have the possibility of 2, we can make the possibility of 2. 2 is called as pair, 4 is called as quad. Don't care conditions. Cells marked X can be grouped as 1 or 0 to simplify circuit. It can be used only when they are needed to grouping. Otherwise, we can leave them. Don't care conditions are used when the grouping is possible. If we take the don't care condition, we have the possible value of grouping, highest possible value of grouping. Either we leave it. Don't care conditions are used only if they are used, they can form a possible highest grouping. Advantages and limitations of K-maps. Advantages are simple visual method, reduces logic complexity, more reliable than algebraic simplification. It is much easier than using logic gates, not limitations, not practical beyond 5 or 6 variables. If we use 5 or 6 variables, there is a chance of confusion. It becomes complex to draw and it becomes complex to group it. For larger variables, we can use the Quine-Mikulskian method, which is also known as tabular form method, and it is preferred for larger variables. Applications: digital circuit design. It is used as in digital circuit design. It is used in simplification of combinational circuits, used in CPU design, memory units, ALUs, etc. Conclusion: K-maps provide systematic simplification, reduce hardware cost, speed up design, still essential in understanding digital logic design, etc. K-maps can reduce the logic gates and it is represented in the shortest form. It reduces the variables number of variables, it reduces number of gates, and it is used for small variables. K-maps can provide systematic and smallest simplification method. We can reduce use any gates in the K-maps. It reduces the cost and it speed ups the output. It speed ups and gives the output fast. Still essential in understanding digital logic design. It is much easier to use K-maps in used for small variables. Thank you.